Alright, this is lesson 6.1. In this lesson, we are going to find the sum of the measures of the interior angles of a polygon, and we are going to find the sum of the measures of the exterior angles of a polygon. Anyway, a couple of review things that we need for this chapter. We need to remember the properties of parallel lines. So in this first problem, you'll notice that x plus 9 and 2x minus 21, since these two lines are parallel, they are corresponding angles, so they are equal by the corresponding angles postulate. And then you can solve that. Number 2, I think they're talking about these two angles, and since these two lines are parallel, those are same side interior angles, and by the same side interior angle theorem, those should be supplementary. So if we add those up, we should get 180 degrees. And on the last one, those angles are alternate exterior angles. So by the alternate exterior angle theorem, 5x has to equal 176 minus 3x. And then you can go ahead and solve those. Determine whether AB is parallel to CD. I believe AB is parallel to CD here because we have alternate interior angles, and so by the alternate interior angle converse of the alternate interior angle postulate. I believe it's a postulate. Can't quite remember, but we have AB is parallel to CD. In this one, if AB is parallel to CD, that would tell us that these two corresponding angles would be the same, so we'd have to check that. So see if 3x plus 18 is equal to 4x. That's true. And at the same time, we have a triangle here, so by the triangle angle sum theorem, we would have 3x plus 4x plus 2x is equal to 180. So if you get the same value of x for both of those, then you can determine that AB is parallel to CD. And then the last one, if AB is parallel to CD, here we have some vertical angles. So 2x plus 11 must equal 3x minus 9. And at the same time, we have corresponding angles here. Whoops, sorry about that. We don't have corresponding angles there, but we have same side interior angles there. So it also has to be true for those two lines to be parallel that 3x minus 9 plus 6x plus 9 is 180. If both those are true, then AB would be parallel to CD. Okay? Using slopes to determine if they're parallel, perpendicular, and either parallel have same slope, perpendicular have opposite reciprocal slopes, and other than that, it would be neither. So if you look at number 7 here, you notice they have the same slope, so you know those are parallel. If you look at number 8, if they're opposite reciprocals, that means their product would equal -1, which is true here because we get -15 divided by 15, which is -1. So those are perpendicular because we have opposite reciprocals. And then this last one, if we rewrite these, and I'll let you do the second part of this, but so if I subtract 2x from both sides, then I get -3y is equal to -2x plus 1 divided by -3, and I get y is equal to 2/3 x plus 1. Likewise, simplify the other one and check out the slopes, see if they're the same or opposite reciprocals. To prove triangles are congruent, I think we're going to need a little bit more here. Here we have congruent side. Since we have parallel lines, we have lots of angles that are the same. Like this angle and this angle would be the same because of the alternate interior angle postulate. And also we would have these angles are the same by the same postulate. So using the alternate interior angle postulate, or maybe it's a theorem, I don't remember, but and also reflexive property, we have by angle side angle that the two triangles are congruent. In the second one, we have the reflective property there, so those are the same, and if that's a right angle, then so is that. All right angles are the same, so we have side angle side on this one. And on this one, the one extra thing we have by vertical angle theorem, we have those two angles are the same, so we have angle side we can use on that one. All right. So you can go ahead and do the vocab here. I'll put up the answers. All right, here's one of the theorems we're going to use, the polygon angle sum theorem and corollary. The sum of the measures of the interior angles of an n-gon is quantity n minus 2 times 180. The measure of each interior angle of a regular n-gon is quantity n minus 2 times 180 divided by n. Remember that regular means that all the angles are the same and all the sides are the same. So when n minus 2 equals 1, that means n is 3, the polygon is a triangle. And when n minus 2 equals 2, the polygon is a quadrilateral. All right, finding the polygon angle sum. What is the sum of the angle measures of a ten-gon? I'm going to get a ten-gon up here, otherwise known as a decagon. All right, it says we want the sum of the angle measures. All right, the way we can go about figuring that out is, if you think about this, if I draw from one vertex all the possible lines that connect it to the other vertices, if I do that, I can connect to every vertex except the two that are right next to it. So I can connect to 10 minus 2 vertices. And then each of those make a little triangle, and the number of degrees of the angles in any triangle is 180. So if I just take 10 minus 2, which is 8, times 180, I get the total number of degrees in a decagon. So 8 times 180 is equal to 1,440. So the total number of degrees of decagon is 1,440. All right. So if we have a 17-gon, I'm going to change this to 15 so that we can use this 15-gon here on your paper. That's 15 sides I checked earlier. So we're going to do 15 minus 2. Actually, when we write the formula, we just write n minus 2. And 15 minus 2, that's 13 times 180. So we got to simplify that. And that's 2,340. Now, if we want to check that, it says draw the diagonals. You go ahead and do that if you want, but it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and I miscounted 13 of them. All right, Marcy creates a floor tile pattern using squares, regular hexagons, and regular dodecagons, 12-sided polygons. What is the measure of each angle in one of the regular dodecagons? Well, what we can do is figure the total by using the formula we just learned. So n minus 2 times 180 is the total. And so 12 minus 2 times 180. And that's equal to 10 times 180, which is 1,800. But we can just divide that by 12 because regular polygon is equal angular. And if we divide that by 12, we get 150. So the measure of each interior angle in a regular nonagon is 40. All right. What is the measure of angle D in the quadrilateral? All right, so using the angle sum theorem, we know that the measure of angle A plus the measure of angle B plus the measure of angle C plus the measure of angle D is equal to, I'm just going to do it the quick way here. I'll divide this into 2 times 180, which is 360. And so we can substitute for A, 98, for B, 91, for C, 112. And we can combine all of those numbers together and we get 301 plus the measure of angle B is equal to 360. So the measure of angle D is equal to 360 minus 301, which is 59. Go ahead, you do that. All right, I'm going to stop the video here, and we're going to have to do a part 2.